All right, this is what we have today. No, this is not a Tesla motor, but it does looks like, huh? This is a motor from a Graco 380 spray machine. And this little guy costs roughly around 700 to 1,000 bucks. Well, what's good about these guys, well, they run without problem for a long time until you overuse and abuse them. Usually it starts when this right here, they get all, as you can see, kind of squished together, and it's not perfect anymore. And besides that, there's more electric current going in through the coil, which creates uneven spin. And the reason why that can happen is because it's poorly constructed. And the second reason is these wires right here, they have covered with special non-conductive material. What happens to them when they get hot? That covering material gets burned out from the heat, from excessive heat, and it, as you can see right here in the core, there's a corrosion right there. That sign is, that green is usually when copper corrodes. This is a sign when the copper is touching the water. Okay, you can see the green, that's an oxidation of copper. Usually copper turns to green. If you have a penny and throw in the water, it's going to turn to green for a while. It's sitting there. Copper doesn't like water too much, and there's not other metals that like water too much except stainless steel, titanium. Those are good. But anyways, well, this is a copper, and that's what happened. And we're gonna have to decide to replace or repair. Replacing is really expensive. We're gonna have to find exactly the same part, and hopefully the manufacturer has some kind of warranty on these things. They can replace everything for us. If they don't, then we're gonna have to disassemble the entire core, take every little pin out from here, as you can see. We're gonna have to take all this out and put it back. The wires, maybe run the brand new set of wire. This is copper, slightly expensive, but that's how it's gonna be done. This is pretty much the small Tesla motor. That's how that's all the motors are electric motors, okay? But Tesla is designed a little bit differently. They do a lot of research and a lot of diagnostics before they put anything into the cars, but that's similar to the motor. And there is a cover, magnetic field around it. This one goes into the magnetic field. There is a magnetic, like a cover, and that's when it starts working. These motors are very, very precise, and they're very precisely designed and all that, as you can see. And also another thing, when you assemble these motors, they have a certain way of wrapping these copper wires. As you can see, they're nicely wrapped, and every wrap, every bunch has a specific frequency in order to keep the motor running efficiently. All right, well, thanks for watching, guys. I hope this helps you a little bit to understand how the electric motors work and how they built. And as you can see, this part is also copper, which is a highly conductive. You get your two positive and negative wires connected from these sides, both sides, and also they conduct through the magnets. They call it brushes. The brushes sit right here, and when this thing spins, that's what it happens. Magnetic field is created, and the motor starts spinning in a crazy speed. Okay, so that's how the motors are built. me try to see. Here we go. As you can see, in my hand, it's even so smooth and so nicely designed. As you can see, this is how they work. This is how it's made to work. You can see the nice bushings here and all that. Very nice, beautiful design. Got the nice thread to connect to the rest of the machine to move the parts and motors. Well, thanks for watching, guys. Follow for more.